Hey guys, so this video is to teach you how to do round robin scheduling for our assignment for subject in operating system. So first of all, I'd like to introduce my groupmates. Consists of me, Sheng Hong Chin Han. Second one will be Chiu Gin Xiang. The third one will be Li Hao Chun, and the last one will be Guo Jie Jing. So I'll start with the steps. For round robin, it consists of 3 steps. The first one will be do the quantum. Second one will be finding the possible value, and third one will be finding the balance and execute it. So as you can see, these are all, they list down the processes and all the burst time, overtime priorities. And here is the quantum they give you. The quantum is 3. Okay. So you have to find the first column first. So you put 3 here, and then you find for the you have to find the based on the arrival time. The number you have to find based on what is between 0 and 3, based on the arrival time. So basically it's 2, because it's between that. So we start with 2. So after that you move the burst time, it will be 5. So you put 5 here, make a diagram and put 5. Okay. Then after that, the second step will be finding the possible value. Okay, you already done that. Okay. Then you move to the second column, which is the next one will be P1. So for P1, that's not P1 because that's the next one. After 0 will be 2. So it will be 2. Then you look at the burst time. Burst time is 4, right? So P1 equals to 4 here. Okay. And then after that will be a third step. Third step will be finding the balance and execute it. So first of all, you execute P2 first. So, you take 5 minus 3 because quantum is 3, right? So you take 5 minus 3 and you bring it down here. Okay. So it will be, so the balance will be equals to 2. Okay. So it will be P2 equals to 2. Alright. So once you get 2, you know that, so you already know how many times you need to go to the next line. Okay. So you plot, so you see the starting point is 6. So it's 6 plus 2. So you become 8. And then you insert the process P2 here. Right? Then after that, you move on to the next one, will be P3. Okay. P3 arrival time is 4. Then you look at burst time is 6. So you put 6 here. Okay. Then after that, you have to plus by 3, which is 11 because quantum is still 3. So it plus by 8 will be plus 8 plus 3 will be 11. 11. Okay. And then you execute, which is you find the balance and execute. So you look at P1, 4 minus 3 is 1. So you bring it down here. You put it down here and you put P1 equals to 1. This is the balance of P1. Okay. So you know now you know how many times you need to jump to go to the next line. So it plus 11 plus 1. Okay. It becomes 12. And then it will be P1 here. Then you put P1. Then the last one will be the last execution you need to do. Alright. So now you need to execute P3. So P3 is equal to 6 based on the first time 6. So you bring it down, you minus 3, which is the quantum. 3 is the quantum. And then you put P3 equals to 3. This is the balance of P3. Okay. And then you know, now you know how many times you need to go to the next line. And you plus 12 plus 3 equals to 15. Okay. And then you put the process P3, and there you go. You got the Gantt chart. The Gantt chart for this question. Now we'll move on to the next one. It will be to find the waiting time for each process. So we start for P1, from P1 first. So for P1, we'll start from here. So the formula for waiting time is the starting point here minus the arrival time. So 3 minus 2, how do you get that is you will look at the 3 here, 3, and look at the diagram again, which is here. Look at P1. The arrival time is 2, right? So it's 3 minus 2, okay? But since there's another process happening in this Gantt chart, so you have to look at another one. So for this another one, right, you have to look at the arrival time again. I mean the previous arrival time for P1. So previous arrival time is 6, right? Because that's where it's finished at 6. So you take the starting point of P1 and the previous one is 6. And 11, so you put 11 minus 6. So equals to 1 plus 5, and it will be equals to 6. So that is the waiting time for 6. Okay. Now we'll move on to P2. For P2, you have to take 0 minus 0 because the starting point of P2 is for the first P2 is 0, and P2 the arrival time for P2 is 0. So 0 minus 0 equals 0. Then plus by 6 minus 3. Okay. So from here you see 6. You take the previous one, 3. The finish time is 3 and 6. So you take 6 first, starting point of P2 or the second P2, 6 minus 3. And then you get 3. That is the waiting time for P2. And after you move on to P3. So for P3, it's the same thing also. Look at the first one. For P3, starting point is 8, arrival time is 4. So 8 minus 4 plus by 12. 12 minus 11. So 11 you get from the ending point of P3, the first P3. So you take 12 minus 11. And you get 4 plus 1 and equals to 5. And 5 is the waiting time for P3. So right now it will be the last step, which is to find the average waiting time of all the processes. So you take 6 minus 3, 6 plus 3 and plus 5 divide by 3 because there's 3 processes. So you have to divide it by 3. So after that you get 4 over 4 divided by 3, and then you'll get the total of 4.67. Actually, it's actually 666 over plus 667, but you just have to round off to the 2 decimal places to be safer. Okay. So yeah, that is all for me of the explanation of round robin scheduling. Now I'll pass it to my other group mate, Chu Gin Xiang, to continue with the video. Thank you.
Hey guys, I'm Chu. So I'm going to continue with the second question. Okay, so as we can see, this question has 5 processes. So okay, first thing, we have to do the quantum. You can see the quantum equals to 5. So we do 0 to 5 first, then we list it out in the table accordingly. So we can see P3 will come in first at the arrival time of 0, and then P2 comes at the arrival time of 2. So we list it down, P3, P2, and then this will be the burst time. Okay, after we list down all the coming in processes, we choose the top to do first. So we write here P3, and then we find the balance. So the burst time needs 9, and then we have done 5. So 9 minus 5, we get 4, and then we update the table for the balance. Okay, and then we move on to the next one. So from 5 to 10, what is going to come in? We can see that P5 coming in, and then P4, and then P1. So we list it down. P5 5 this time, P4 6, and then P1 10. So after we list down all the possible coming in process, we choose the top. So this one already done, and then it will be the next for this one. So P2 is doing, and then 15 minus 5, we will get 10 balance. So we update here, and then yeah, the same. So we do it for the third one. So we have to do the top one first. So it's going to be 14 because the total burst time need to be fully execute the process is 4 only. So from 10 we do until finish, it's 14 only. So we write it down, P3 and then 10 to 14. So there's no need to balance since it's already done. So we'll continue with P5. P5 also the same. We're going to need 5 only, so 14 to 19, and then the next one will be P4. And then since P4 is going to have a balance, so we do it from 19 to 24, and then 6 minus 5 we balance 1, and then we update it. And then the next one we have to do P1. So P1 goes from 24 to 29, which is going to do 5, so 10 minus 5 equals to 5, we balance it. And then next we do P2, also 5, so 10 minus 5, 5. Yeah, update here. Okay, and then P4, 1 only, so we add 1 only, 34 to 35. Okay, done. And then the rest also is going to be done. Okay, P1 5 and P2 5. Okay, so to double check, we can add up all these burst time together and then compare with the total time used. So if it's going to be correct, it's going to be the same, 45 and 45. Okay, so now we move on to waiting time. We have to find the waiting time for each of the process. So we start with P1 first. So we find the first execution point for P1. So it's 24, and then minus the arrival time of it, which is 8. So and then we plus the next execution time, and then minus the previous ending time to find the waiting time. So it's going to be 16 plus 6, we get 22. And then for P2 we do the same. It's going to be first time do at 5 and then arrive at 2, and then the next one would be 29 and then minus the previous ending 10, and then 40 minus 34, and we'll get 28. And then for P3, since P3 is executed by the time it arrives, so 0 minus 0, and then the next one will be 10 minus 5, so we get 0 plus 5, we get 5. And then P4, the first time doing P4 is at 19, and then minus the arrival time 7, and then plus the next one 24 minus the previous ending 24, and then laid up we will find 22. So for P5 we do it the same, 14 minus the arrival time, which is 6, so we get 8. So to find the average arrival time, we have to add up all the waiting time for each processes and then divide by the number of processes. So in this case we've got 5 processes, so we divide by 5. So 17 will be the answer. So I hope you enjoyed this video. Thank you.